Yes, I am G.K. Raghavan, chemistry faculty from Alfords College. So today, session 4, chemistry e-learning program. So in this session, we will discuss about isoelectronic What is that isoelectronic species? The species containing the same number of electrons are called isoelectronic species. The species containing with same number of electrons are called isoelectronic species. For example, Cn minus, cyanide ion, Cn minus, the number of electrons present in this Cn minus, that is carbon atomic number is 6, it has 6 electrons, and nitrogen atomic number is 7, and the nitrogen, that is one negative charge, that means one electron is excess. So total number of electrons are equal to, that is 14. So this cyanide ion, Cn minus ion, has isoelectronic with carbon monoxide. Carbon monoxide, atomic number of carbon is 6 and oxygen is 8. So total number of electrons, that is again 14. Next, let us take another one. It is N2 molecule. So nitrogen atomic number 7. So 2 nitrogen atoms, that is 7 plus 7, that is equals to 14 electrons. So the species means it may be ion, molecule. Okay. So the species containing the same number of electrons are called isoelectronic species. Species with same number of electrons. Okay. Now let us take isoelectronic series. Isoelectronic series. Now it is in the series. The series of elements possessing, that means the ions or it may be atoms possessing same number of electrons. Series, in this it is observed in the series. For example, let us say carbon C minus 4, N minus 3, oxygen O minus 2, fluorine F minus 1. So carbon atomic number 6 plus 4 extra electrons, that is 10 electrons total. Nitrogen 7 atomic number plus 3 extra electrons, that comes again 10 electrons. Oxygen atomic number 8 with 2 extra electrons, that is minus 2. So total it becomes 10 electrons. Fluorine atomic number is 9 plus 1 unit negative charge, that is 1 extra electron. The total electrons becomes 10. So all these ions possessing the same number of electrons, therefore they belongs to isoelectronic series. One more example let us consider. They are all negative ions. Let us take positive ions, that is cations. Sodium ion Na plus, magnesium ion Mg plus 2, and aluminium ion Al plus 3. Sodium atomic number 11 plus 1 means loss of 1 electron, so it contains 10 electrons. Magnesium atomic number 12. So plus 2 means it has lost 2 electrons, and the total number of electrons present in this Mg plus 2 ion are 10. Aluminium atomic number 13. Plus 2 plus 3 means it has lost 3 electrons. Now the total number of electrons present in this is 10 electrons, 10 electrons, and here 10 electrons. So total we can call them as isoelectronic series. Okay, this is the concept of isoelectronic. So isoelectronic means the species with same number of electrons. The species with same number of electrons are called isoelectronic species. With same number of electrons, they are isoelectronic species. Example is carbon monoxide, nitrogen molecule, and cyanide ion. They possess the same number of electrons, that is 14 electrons, 14 electrons, 14 electrons. that is called isoelectronic series, that is isoelectronic species. Now isoelectronic series, the series of ions containing the same number of electrons, the series of ions containing the same number of electrons is called isoelectronic series. They are belongs to isoelectronic series. Okay, so they are isoelectronic series. C minus 4, 10 electrons, 10 electrons, 10 electrons. They contain 10 electrons total, right? So this is about isoelectronic series. Okay, so that is in the last session, that is in the session number 3, we completed isotopes, isobars, isotones, isodiaphers, isostars, and in the session 4 we are doing now isoelectronic. And coming to the next topic of atomic structure is light, nature of light. Nature of light. The next topic is nature of light. Nature of light. What is mean by light? Light is the form of energy. Light is the form of energy. And what is nature? What is the nature of light? So the nature of the light was explained by the different scientists according to the different people. So the opinion of the light is different. So that is according to Newton. According to Newton scientist. According to Newton. Light. The nature of light is particle nature. So according to Newton, the nature of light is particle nature. Particle nature of light was explained by Newton. So that theory he proposed, that is called corpuscular theory. That is particle theory. Particle theory was explained by Newton. According to Newton, the light is made up of large number of invisible stream of particles. Light is made up of large number of invisible stream of particles distributed uniformly in all directions in straight lines. That is the nature of light according to Newton. Say for example, so let us see light. Okay, so now light is made up of large number of invisible stream of particles. Invisible stream of particles. So all these are the particles. Invisible stream of particles distributed uniformly in all directions in straight lines. That is the light according to the Newton scientist. That is particle theory or particle nature of light, corpuscular theory, or we can say particle theory also this. So that is explained by Newton. Okay, that is Newton proposed particle theory of light, that is particle nature of light, that is called corpuscular theory of light. Okay, and the next theory is wave theory. Wave theory was explained by scientist. Wave theory was explained by the scientist. Wave theory was explained by the scientist Huygens. Huygens explains wave nature of the light. So according to Huygens, it is, he proposed wave nature of light. Wave nature. Wave nature was explained by Huygens. According to Huygens, light is made up of, large number of invisible stream of waves distributed uniformly in all directions in straight lines. That is the nature of light according to Huygens. He proposed wave theory. Wave theory. Wave theory was explained by Huygens, scientist. Okay, you can say wave nature of the light, or it is nothing but the wave theory which was explained by Huygens, scientist. According to Huygens, once again the light, according to Huygens, light is made up of large number of invisible stream of waves distributed uniformly in all directions in straight lines. That is the nature of light according to Huygens, that is wave nature of the light. Okay, now let us see the advanced theory, that is Maxwell's theory, that is called electromagnetic nature of light. Electromagnetic nature of light. Electromagnetic nature of light, that is, this was explained by Maxwell. It was explained by Maxwell, scientist. According to Maxwell, light is made up of large number of invisible stream of electromagnetic waves distributed uniformly in all directions in the straight lines. That is the nature of light according to Maxwell, scientist. So Maxwell proposed electromagnetic theory, that is electromagnetic nature of the light. Okay, so this electromagnetic light, the electromagnetic light is made up of, electromagnetic light is made up of two component waves. Say for example, the source of light, this is the direction of electromagnetic wave. Say this is x-axis, z-axis, y-axis. Okay, now according to Maxwell, so the electromagnetic light is made up of two component waves. Two component waves. Two component waves. Say this is electric field component wave. Electric field component wave. The second one, let us say, for the identification of this one, let us mark like this. It is electric field component wave. Electric field component wave, and the second one is magnetic field component wave, that can be perpendicular to this. Electric field component wave, the second one is magnetic field component wave. That magnetic field component wave, these two are perpendicular to each other, propagating in the direction of the light. So that is, one is electric field electric wave, that is electric field component wave. The second one is magnetic field component wave. Okay, these two electromagnetic waves, that is electric field and magnetic field component waves, they are moving perpendicular to each other. That is electromagnetic nature of light according to Maxwell, scientist. Okay, this is the Maxwell theory, that is electromagnetic nature of light. He explained electromagnetic theory of light, that is Maxwell. Then next, after this electromagnetic, now properties of electromagnetic light. Properties of electromagnetic light. Let us discuss about the properties of electromagnetic light. See, what are the properties of electromagnetic light? Electromagnetic light has the following properties, such as, number one is wavelength wavelength, and number 2 is frequency, and number 3 is, say it is wave number, and third one, fourth is velocity of light, and fifth is amplitude. So these are considered as the properties of electromagnetic wave. Okay, now let us discuss details of the properties of electromagnetic wave. Okay, properties of electromagnetic wave. First one, let us discuss about the first one is wavelength. Properties of electromagnetic wave. First one is wavelength. Yes, the important points we can write like this. Wavelength. The distance between successive crusts, or trough. The distance between successive means adjacent crusts. It is crust, it is trough. The distance between the two adjacent crusts or troughs known as wavelength. That is the definition of wavelength. The distance between adjacent crusts or troughs known as wavelength. Okay, it is denoted, that is the first point, we can say the definition. And now the second point is, it is denoted by, that is wavelength is denoted by lambda. It is denoted by lambda symbol. This is lambda symbol. Once again the definition, the distance between two successive crusts, that means adjacent crusts or troughs, known as wavelength, that is. Next, it is denoted by the symbol lambda. Okay, then wavelength expressed in the units, wavelength of the electromagnetic light expressed in the units of angstrom units, nanometers, picometers. Angstroms are in nanometers or in picometers. Okay, let us see some conversions of this. 1 angstrom unit is equals to 10 to the power minus 8 centimeters, or 10 to the power minus 10 meters. 1 nanometer is equals to 10 to the power minus 7 centimeters, or 10 to the power minus 9 meters. This 10 to the power minus 9 meters, that is equals to 1 micrometer. That is equals to 1 micrometer. That is equals to 10 angstroms. That is equals to 10 angstroms. 1 picometer is equals to 10 to the power minus 10 centimeters, or 10 to the power minus 12 meters. So this is about important conversions of wavelength. Okay, so this is Wavelength, first once again the definition part, that is the distance between two adjacent crusts or troughs is known as wavelength. It is denoted by lambda, and wavelength of the electromagnetic light is expressed in the units angstroms, nanometers, and also expressed in picometers. Okay, this is angstroms. This is nanometers. This is picometers. Okay, now the second property of electromagnetic light, that is frequency, frequency of the light. The next definition is frequency of light. Frequency of the light. So frequency can be defined as the number of waves passes through a fixed point in 1 second. Number of waves passes through a fixed point in 1 second. The number of waves passes through a fixed point in 1 second is known as the frequency of the light. And the second point is, it is denoted by the symbol Nu, that is like this, nu. And frequency of the electromagnetic light is expressed in the units to express frequency of the light, that is per second. That is SI unit is per second. Okay, that is nothing but Hz, that is hertz, or we can say cycles per second, CPS, cycles per second, that is frequency of the light. Okay, and what is the relation frequency of the light with wavelength? So the relation between frequency and wavelength, relation between frequency and wavelength, that is nu is equals to C by lambda. That is the relation between frequency and wavelength of the light. Okay. So frequency is always inversely proportional to wavelength of the light. See, in the electromagnetic spectra we know that. So we have the various electromagnetic radiation lights, various electromagnetic radiations. They are arranged in the increasing order of wavelength or decreasing order of frequency. Like from the beginning we have cosmic rays, gamma rays, X-rays, UV rays, visible light, then infrared rays, then microwaves, and last one is radio waves. So all the electromagnetic radiations are systematically arranged in the increasing order of their wavelength, or that is nothing but the decreasing order of their frequency. Okay, so that is cosmic rays are having maximum frequency and radio waves are having maximum wavelength. Okay, so suppose if we talk about cosmic rays to radio waves, so wavelength increases, frequency decreases. Okay, so that is relation between frequency and wavelength. So among all the electromagnetic light, So which electromagnetic light possessing maximum wavelength, that is radio waves. Among all the electromagnetic radiations or electromagnetic light, the light which possessing minimum frequency, that is nothing but minimum frequency means maximum wavelength only, that is nothing but radio waves only. Okay, so that is about frequency of the electromagnetic light. Okay, and the next property, that is wave number. Okay, before going to take up that wave number, let us see here in this only. So we had the relation between, just now we had the relation, that is nu is equals to c by lambda. Nu is equals to c by lambda. That means we can calculate frequency and as well as lambda. The c is nothing but the velocity of light, that is a constant value. Velocity of light, it is velocity of light. Velocity of light. The value of this light is constant, that is 3 into 10 to the power 10 centimeters per second or 3 into 10 to the power 8 meter per second. That is velocity of the light is considered as constant. That is constant. Okay. Now let us see some more relation of this. Suppose electromagnetic lights having two different wavelengths and their frequencies are related as, for example, like this, nu1 by nu2 is equals to, nu1 by nu2 is equals to lambda 2 by lambda 1. That is wavelengths of two electromagnetic lights, wavelengths of two electromagnetic lights and their frequencies are related because frequency is inversely related with wavelength. So they are related like this. So these formulas are important for objective point of view for EAMCET as well as for main examinations. Okay, that is the content for frequency. Now let us take up the wave number. The next property is wave number. Okay, slowly let us learn all these topics which are very simple and easy to understand. The thing required in this is we need regular practice. So now wave number. Wave number. The definition of wave number. The number of waves present in 1 centimeter distance is known as wave number. The number of waves present in 1 centimeter distance. Number of waves in 1 centimeter. Number of waves in 1 centimeter distance is wave number. Okay, it is denoted by the symbol nu bar, that is nu and nu bar. It is denoted by the symbol nu bar, that is wave number. Wave number is reciprocal of wavelength. That means nu bar is reciprocal of wavelength. That means if wavelength is more, then wave number will be less. Okay, for example, let us consider, say this is, say for example, I consider this 1 centimeter distance and it is again 1 centimeter distance. Now let us say one wave is accommodated in 1 centimeter distance. So that is 1 centimeter distance. In this, how many waves are accommodated? Only one wave is accommodated. Now this is wavelength is more, that is why it is wave number is only 1. Let us make different. So now wavelength is less, so therefore wave number will be more. So that is why we can say wave number is reciprocal of wavelength. It is reciprocal of wavelength. Okay, so now that is concept of wave number, and wave number expressed in the units. Wave number expressed in the units of it is expressed in the units of, that is lambda, wavelength expressed in centimeters or meters. So it is centimeter inverse or meter inverse. That is wave number expressed in centimeter inverse or meter inverse. That is wave number. Okay. So what is the relation of wave number with wavelength? It is inversely proportional. Okay. It is inversely related. That we can understand one concept. Next, what is the other relation with frequency? Frequency, other relation, nu is equals to C into nu bar. Nu is equals to C into nu bar. That means frequency and wave number, they are directly related. They are directly proportional. Okay, that is relation between frequency and wave number. Whereas, see, let us, from this relation we can understand, see, the wave numbers of the two different light, and their wavelengths are related as, like nu bar 1 by nu bar 2 is equals to, they are inversely proportional, reciprocal. So therefore it is lambda 2 by lambda 1. That is important for objective examination point of view. Okay. Right, this is concept of wave number. Okay, wave number is reciprocal of wavelength. Okay, so right, the concept of wave number is done. So far we completed wave length, frequency and wave number, and next coming to that is velocity of light. Velocity of light. What is the velocity of light? Velocity of light. Yes, the interesting definition of the velocity of light. The distance travelled by the light in 1 second is known as velocity of light. The distance travelled by the light per second. Okay, distance travelled by the light in 1 second is known as velocity of light, and it is denoted by the symbol c. Okay, velocity of light, it is denoted by the symbol c. Okay, then the question arises, we have different electromagnetic radiations are there. That, like just now we had that discussion about that, that is electromagnetic light. Various kinds of electromagnetic light, such as gamma rays, X-rays, UV rays, visible light, infrared light, microwaves and TV waves. So different kinds of electromagnetic radiation. So they may travel with different speed. So for the propagation of this light, they required medium. So in the different media, the speed of the light may be different, but the electromagnetic light can travel in vacuum. In vacuum, all electromagnetic light travels with same speed. That is one important point. So all electromagnetic light electromagnetic light, all electromagnetic light travels with same speed, it travels with same speed in vacuum. Remember, that is important. In vacuum, travels with same speed in vacuum. Okay, so that is why the velocity of the light is considered as constant value, that is 3 into 10 to the power 10 centimeters per second, or C is equals to 3 into 10 to the power 8 meter per second. That is the velocity of light is considered as constant value. Okay, that is the concept of electromagnetic light. Now coming to the next one is, we completed the electromagnetic light, that is velocity of the light is done, and coming to the last one is amplitude. Next property is amplitude. See this velocity of the light. So as we know that sometimes you can also expect a EAMCET bit like, so nu is equals to C by lambda. We understand that nu is equals to C by lambda. C is equals to, it is a product of frequency and wavelength, isn't it? So velocity of light is the product of frequency and wavelength of the light. Okay, like that also you can expect the objective question. Yes, now coming to the amplitude. Amplitude. Yes, the easy definition of the amplitude is, it's simple. The height of a crust, or depth of a trough, is known as amplitude. Height of a crust or depth of a trough, it is crust and it is trough. Height of a crust or depth of a trough. Rather we can say another way, that is the displacement of the electron wave, the displacement of the electromagnetic wave, that is called amplitude. Okay, height of a crust or depth of a trough, that is amplitude. Okay, amplitude is denoted by the symbol A. Okay, and it is expressed in the units height, centimeters, or it is also expressed in meters. Okay, so that is about amplitude.